Alright, this is the solution, or at least my solution for the video that we saw previously, where I'm giving you a partial implementation of a project and you need to go off and create the classes and the inheritance between those classes in order to make this code function correctly as outlined in the README file and then that sample output.png. So you should only watch enough of this to get unstuck and then you can continue on. Or you can look at it after you've completed just to watch how I would have solved this. But without further ado, let's go ahead and start by creating a new class. We're going to call it player. We've already determined that there's a relationship between player, probably the parent class, and warrior wizard, which are the derived classes, right? So here we go. Let's go class player. And we already know that there's going to be a name, which is a string, and a strength, which is an int. So let's go ahead and just implement those members. So string, name, and strength. And then we also know that there's going to be an attack method. We need to implement that. So let's go ahead and we'll go ahead and make it public. It really doesn't matter. Public void attack. We'll start there and I'll add more to this later. Okay. And so we know that we're going to have a console.write line and it's going to be something like, let's just go ahead and template that out. The name property will be used, attacked for, and then an amount property that we need to generate, right? So here we'll go with something called the amount, right? And I'm going to use string interpolation, so I'll use the $sign before this and it'll pick up that name property. Now we just have to create the amount property, all right? So we said we're going to use the random class. This might be where you got stuck if you don't remember how to do this. So random is the class. Lowercase r random will be our identifier for an instance of that class, equals new random. And then we'll call random.next. And we said we were going to use the strength as the max value or the upper bound. So we're using the strength property from the current instance. Now, by all rights, we probably should check to make sure that the strength has a value greater than 0, that it was instantiated correctly. I'm taking great liberties here by not doing an extensive amount just so we can get to the core value of this example, which is to look at the inheritance side of things. So var amount equals random.next strength. And so there we have an implementation for the player. And that should satisfy our first one. We have a name, strength, player. We're able to add the player to this collection of players and so on. All right. So now what we need to do is create the two other classes. And so we'll start with the warrior class. So class warrior, and we're going to need to inherit from player. We already determined that because we saw that there was a relationship there. We don't have to implement the name and the strength. But if you take a look back here at the README, there was going to be a bonus attribute that we need to implement. So let's go ahead and do that. So go prop tab int bonus, enter enter. And then what we want to do is actually create our own implementation of output, or I'm sorry, of the console.write, and it needs to match what we see here. The name of the warrior charges for the amount of damage, includes a +10 bonus. So let's go ahead and I'll just minimize that for the moment. And so we're going to do public void attack. And this is where we're going to get into our inheritance stuff a little bit more as we go and try to do another random equals new random. And then we can go var amount equals random.next. And then we'll do the strength property. The only difference here to this little tiny algorithm is that we're going to add on the bonus, which we know is 10, but I just wanted to type that there like that. So now we're going to include that in. And then the other change to this version of the method write line is that we're going to change up what's actually in here. So we'll use the name charges for some amount of damage, which includes the plus bonus. I think that'll pretty much do it right there. Now, we haven't exactly implemented the relationship here correctly, because what we need to do is mark this as virtual and mark this as override. All right, so that should implement the warrior. Now let's move on to the wizard. Class wizard derives from player. And in this case, we know that it has an energy attribute, which we're going to make an integer. So prop tab int energy. And then we're going to also do a public override void attack. And notice that when I do that, it automatically gives me the base.attack, which is exactly what we needed in order to get the output to duplicate essentially what we see in the player. So that's perfect. We didn't even have to write the code for that. It just generated it for us automatically. But then the next step of this is going to be to actually do the console.writeLine. And I just used like 5 spaces here and said, and put it in parentheses, I think, wizard, and then we use the name. So let me back up here and make sure that I get this as interpolation like so. Depleted some amount of energy, right? Like that. So now let's just fill in amount. And then we'll come back here and go do the hold a random thing. And if you wanted to extract out this random generation and do its own helper method in the base class, you certainly could have done that. That would have been a nice little example. Although it's only 2 lines of code, may be a little overkill. But random, and then var amount equals random dot next. And we're going to, we said it was going to be between 1 and 10, right? So there you go. Do that there. Energy minus equal. Remember, we're depleting energy, the amount that we sent in. So you may have forgotten that step because we didn't really display the total amount of energy. But since we are depleting, I decided to go ahead and update the state. If you missed that, I wouldn't count it against you. It would only come in handy later in the game when we had to consider the current state of the wizard and what his current energy was, because he's depleted some of it already, right? All right, so if I did everything correctly, and just a little glance here, that looks right, that looks good, that looks good. We should get similar results to what we saw in the image. So I'm going to run the application, and all right, it looks pretty close. So I may have been a character off or something, or a period or a parenthesis, but that's how I would go about solving it. You know what might be fun here is, just for another exercise, I'm going to create one more video after this one, and what we'll do is extract out those things that are common across all of these. So maybe in this random method, maybe we create a helper method that will actually do this, and we'll see, do we have to create that helper method for each of the child classes? That'll be an interesting little experiment. Let's do that in the very next video. We'll see you there. Thanks.